important, and it's very interesting also. So let us see what we are going to make it. So of course, if you want to prove that more volatile or less volatile, you just pour alcohol on your palm, like your hand, and one hand water. So you can see alcohol, who will evaporate faster, alcohol or water? Everybody, if you go to chemistry lab next time, you can check it. If you pour any kind of alcohol which is not dangerous, you just put it in your hand, and another hand you put water. So which hand you will feel more faster the liquid will evaporate? Which one? Water or alcohol? Everybody? Alcohol. Yes or no? So alcohol, and also see alcohol as soon as evaporating from your hand will become very cool. Sir, why, sir? That is what we will study in our later classes. That is what evaporation leaves cooling. So that we will discuss it always. Okay, guys? So no problem now. So just remember, so now what we are going to study is why the temperature remains constant during melting and boiling, and where that heat energy goes during that time. So that is what we are going to study now. Can you hear me, everybody? All of you? Yes?
Yes, sir.
Yeah. So let us see what is that. Okay. So please all of you keep heading. Why temperature remains constant? Why temperature remains constant during melting and boiling. During melting and boiling, where does the energy goes? Where does the heat energy goes?
How, sir, the temperature will be constant during melting and
Wait, Mari. That is what we are going to discuss now. Okay. Understand? First, listen. Okay. Shall we start now, everybody? All of you. So let us see how I will explain both the concepts. So depending upon the nature of process, one process we all people know. So what is that called as? Converting solid to liquid. What we used to call, everybody? Melting. And next one, liquid to gas. What we used to call, everybody?
boiling.
Liquid to gas
Boiling.
is called as boiling. Yes or no, Nivedan? So melting will take place at particular temperature, melting point. Boiling will take place at particular temperature. What we used to call, everybody? Yes.
Melting point.
Melting point and boiling point. Understand? So let us understand, everybody. So if you notice it very carefully, for example, I am having a one solid substance. I am started heating it. Be very careful. I'm having a solid substance and I'm started heating it. So let me take some solid who's boiling or who's melting point something. Can you tell me what is the substance is having something little other than water? Last class I have told you so many examples. Anybody? Yes. So let me take for example zinc. Can I take zinc? Everybody? What is the boiling point? I'm sorry, melting point of zinc I have taught you? Zn. Melting point, everybody. Melting point of zinc is how much, Ra? 420 degrees. No use like this, you stupid people, always like this. Yesterday I have taught you or not? Melting point of zinc, not day before yesterday. Yeah. So what is the melting point of zinc? How much it is?
420 degrees Celsius.
Let me take. So I have taken a zinc molecules or a zinc substance. You can take it. This is a zinc. Now another beaker I am taking. So which I am taking a liquid. Let me take now a water. Water is very familiar for us. So let me take water now. So we all knows this is water. So what is the water boiling point? Everybody? 100 degrees Celsius. Okay. Now you can see I will fix a one thermometer. Clinical lab thermometer I am fixing at the top, whatever it is, and here also I am fixing at the top lab thermometer. Okay, everyone, clear? So that is what you can remember. Now if I notice it, this is what thermometer, all of you remember that thermometer used to measure what? It is an instrument to measure what, guys? Temperature. Clear? Temperature. Now I am keep on heating. I started heating. Let me take now. Zinc is at 0 degrees Celsius now. So I started heating. So something is increases here also. Let me take now. Both at a time I'm explaining. So all of you observe very carefully. Any doubt you can ask me. Now If you notice it now, let me consider water is also at, water is at 10 degrees Celsius and zinc is also at 10 degrees Celsius. Now, zinc I am heating and here also I am heating. So if I am keep on heating, something will increases. What will increases? Both the cases.
Kinetic energy.
So kinetic energy of the particles increases. Yes or no, Agalya? Of the particles increases. So kinetic energy of the particles increases. What changes will happen? Everybody? The particles will move closer or far each other. The particles will start
Far each other.
far each other. Is it right or wrong? Mr. Sam, no response at all. Is it right? So particles will started moving far each other. Is it right or wrong, guys? Everybody? Yes.
Yes, sir.
So kinetic energy of the particles increases. So the kinetic energy of the particles increases, particles will move. Particles move for each other. Okay, guys. Now, observe very carefully. As the kinetic energy keep on increasing, means the temperature of the particles also keep on increases. So we can see the rise in temperature in thermometer. Here also, I can notice the rise in temperature in thermometer. So particles will energy is keep on increasing. The kinetic energy is keep on increasing. Now, almost temperature reaches to the almost closer to the 420. Let me take 419 degrees Celsius. Here, almost reaches to the 99 degrees Celsius. Or we can take it as a what? Everybody, 100 degrees Celsius. Or here also what will happen? Everybody, 100 degrees Celsius. Understanding, Ra? Sorry, 100 not. What is that? 420. Clear? Now, till 419, what is the state of zinc? Solid state or liquid state? Till 419 degrees Celsius.
Liquid.
Yes, please.
Solid
Till
state.
419. Till
Solid
419
state,
degrees
sir. Solid
Celsius,
state.
the zinc will be in what state? Everybody? Solid state only. But particles kinetic energy increases or decreases? Particle kinetic energy will be more and more. Yes or no? Everybody? More kinetic energy. Yes, Mari? Understood, Nivedan? One. Same way here also.
Yes, sir.
Till 99 degrees Celsius, what is the state of water? It will be in what state?
Liquid.
Liquid state.
Liquid state.
Understanding? So now, after notice carefully, so at this temperature, we can notice the rise in temperature. So as it is energy of the particles increasing, temperature is also rising. Now, as soon as the temperature reaches to its melting point, as soon as the temperature reaches to its boiling point, then the energy, whatever we are supplying, for example, here still I am heating only. So the whatever the energy I am supplying, all of you remember, by the time that energy will never improve the temperature or never rises the temperature. Instead of rising the temperature, as soon as it will reaches to the boiling point, whatever the energy we will supply during that time, that energy will be useful to break the bonds between the atoms. Understand, Ra? Everybody? Breaks bond between the atoms and change of state will begins. Change of state will begins. So that is why during that time, as the entire supplied energy is useful to break the bonds between the atoms. That is what? They will overcome the force of what? By the time. They will overcome something. Just now we studied in the case of boiling. They will overcome the what?
Force of
Overcome the
Force of attraction.
force of,
attraction.
force of attraction. Understanding?
So that means up to 419 degrees Celsius,
Yes.
it will try to break the bond between them, sir.
No, Mari, till that it will gain the energy. Understand, Mari? Till 419, 420 degrees, it will gain the energy to break the bond. Understand?
Yes, sir.
Then, during that time, entire energy, whatever you are supplying, definitely it will be useful to, instead of rising the temperature, it will break the bonds between them. So, once the entire zinc will converting into liquid, then again temperature will increase or decrease, everybody? All of you? Yes? Again temperature will increase. So as soon as the zinc, complete zinc, be careful. Sir, how much time temperature won't rises? Unless the entire zinc will completely converting into what state? Completely converting into what state, guys? Completely converting
Liquid.
into liquid zinc, the temperature rise cannot be seen. Once the entire liquid is converting into zinc is converting into liquid, again we notice the what? Rise in temperature. Do you all understand, everybody? So again, till where it will rise? Again, it will be reaching to the what point? As it is melting point, again it will reach us to the what temperature? Boiling point.
Boiling.
Yeah. So again, same like water also here. So water, I am heating from 10 degrees to 99 degrees temperature or 100 degrees Celsius. So till 100 degrees Celsius, the particles will gain the maximum kinetic energy. So that is why by the time we can see the rise in temperature. But as soon as the temperature reaches to the 100 degrees Celsius, by the time, whatever the energy you are providing, it will be helpful to, instead of increasing the temperature, that energy to overcome the what? Everybody, it will helpful to overcome the force of attraction. That is why during that period, change in state period, we never notice the increase in what? Everybody, increase in temperature. So temperature will be remains constant. Ellame purivuma, understood, guys? So now, as soon as entire liquid, for example, I have given 1 liter liquid water. So entire liquid is converting into gas. Again, the temperature will appears to be increasing or decreasing. Everybody. Yes, please. Respond, Ra. Again, the temperature is appears to be what? Increasing only. Is it okay, guys? Okay, I am leaving the class. Thank you, everybody. You people are not all saying anything what I can do. You understood or not?
Yes, sir.
Yeah.
Yes, sir.
So that is what.
Sir, one doubt, sir.
Yes, ask me, Mari.
Sir, up to which temperature it will be constant, sir?
Entire liquid should be converting into gas, or entire solid must be converting into gas. Then till liquid. Then until that, it will be in a constant temperature. Understood?
Yes, sir.
So once the entire given substance is completely changes its state, then again you can observe the rise in temperature. Purima? Understand?
Yes, sir.
Yes, please. That is what. So this one, at the particular temperature where the particles having maximum energy and there is no increasing change in temperature. So at that point, that is what we used to call as like temperature remains constant during melting and boiling of a matter, as by the time heat energy used to overcome what, guys? Everybody, use it to overcome force of attraction between the particles, and that is why during the time what will happen, the change of something will take place, force of attraction overcomes, then what will happen, change in state occurs. Is it okay, guys? All of you, change in state occurs. So
Yes, sir.
the heat supplied during this melting and boiling remains hidden, or we can say it is like we can say it is not helpful to rise the temperature. It is a hidden heat. That is why that heat is called as the during the melting and boiling, the heat energy which is helping to change in state is only called as what we used to call, Sanjay. Sanjay knows already. 8th class he studied, which we used to call as
Latent heat of
heat,
fusion.
or it is which is very silent. That is what we used to call as silent heat. It is not visible to us.
Latent means hidden.
Yeah, latent heat. Latent heat means the heat which is not
Hidden.
visible to us during the change of state. Understand, Nivedan? Yes? All of you?
Yes, sir.
So let us learn the definition of latent heat. Then for melting, different latent heat. For boiling, different latent heat. So melting also called as what? Everybody. Melting also called as. Also we can know melting another name, guys.
Latent heat of fusion.
Yes?
Fusion.
Fusion.
Yeah, that is what. Latent heat fusion. So that is why for fusion, converting from solid to liquid, we will put like latent heat of fusion. And gas to gas, sorry, liquid to gas, what is to call?
Latent heat of vaporization.
Latent heat of vaporization, or we can say boiling also. You can write it, whatever it is. Latent heat of boiling or vaporization. Shall we start now, everybody? That is what. So first we'll learn what is latent heat, and then latent heat of fusion and latent heat of evaporation. Is it okay, guys? First, right. Latent heat, right. The amount of heat required to change 1 kg of matter 1 kg of matter into another state into another state into another state matter into another state without changing its what? By the time changing that, during the changing state, somebody is constant. Who is constant? Temperature. Changing into another state without changing it what, Ra? Sanjay?
Temperature.
Without changing its temperature. So that is what we used to call as temperature is called what, guys? All of you. Is called as latent heat. Okay, are you able to write it, everybody? Are you writing or not? Please respond. Yes.
Yes, sir.
Okay, next.
Yes, sir.
First one. So for solid to liquid, what is to call? Everybody. Latent heat of what? Latent heat of
Fusion.
fusion. Okay, write it. Latent heat of fusion. Make it. The amount of heat. So what is the energy? What is the heat unit? Anybody? What is the unit of energy or heat energy? Any energy. We know 8th class also you might be studied. Energy unit. Anyone?
Joules.
Joules. Very good. Very good, Sanjay. Write it. Agalia, writing the notes or not?
Yes, sir.
Right. The amount of heat. So we have to take in what? Everybody? Kishore, what is the unit of energy, boy? SI unit. Standard international unit of energy. What is that? Everybody? Joules. Okay? Joules. Required, the amount of heat required to change. This is a fusion, guys. To change one state of what? To change 1 kg of what, guys?
Solid substance.
Of everybody, solid into liquid state.
Liquid.
State at what pressure? At what pressure?
Atmospheric.
Atmospheric pressure. So pressure is always constant. Understand, Nivedan? Sangamitrai? Atmospheric pressure. But by the time without changing what? Without changing its. Without changing its something.
Pressure.
Temperature. Understanding? Temperature means at what point it is? At its melting point. At its melting point is called as melting point is called what is to call?
Sir, how sir it will not change the temperature? There will be some changes, no sir.
How,
Like
Mari? During that time, entire energy, whatever the heat you are supplying, will helpful to break the bond. So never rise the temperature during that particular period. Understand?
yes, sir. Then what will be the temperature at that time, sir?
At the time, what is equals to melting point? Understanding? Melting point is only the temperature by the time. Entire change of state. Clear?
Yes, sir.
That is what. So that is why I'm saying at its melting point is called as what? Latent heat of what, guys? Fusion. Understood, Amma? Yes?
Yes, sir.
Now, for example you can take. So I am having 1 kg ice. I am having 1 kg ice. Now entire ice I want to converting into what state? Everybody? Entire ice I want to converting into what? 1 kg of
Liquid.
what? 1 kg of water. Okay. So what temperature? Water is also at what temperature? 0 degrees Celsius, and ice is also what? Everybody. Ice is also
0 degrees
at 1
Celsius.
kg, 0 degrees Celsius. So now I want to convert 1 kg of ice into 1 kg of water. Understanding? So then you guys knows that how much energy is required. Anybody guess? Yes, please. I want to convert 1 kg of ice at 0 degrees Celsius, then to 1 kg of water at 0 degrees Celsius. Then you know, guys, how much heat energy is absorbed? Anyone idea, please? It will absorb 3.35 into 10 power 5 joules of energy. That much heat energy is will absorb. So heat absorbed to convert 1 kg of ice into completely into 1 kg of water, 3.35 into 10 power 5 joules. This much energy is absorbed. Do you all understand, everybody? So 1 kg of ice at 0 degrees Celsius is able to withdraw from any other body how much energy? Suppose Mr. Sanjay is holding 1 kg ice in his hand. So how much energy it will take from his body to convert into liquid state fully? Everybody.
3.35.
Yes, 3.35 into 10 power 5 joules. So Mr. Sanjay will lose the energy or not? Everybody.
Yes, sir.
Yes, that is what you have to remember. It will take from our body. Understand, Sam? Gokul Raj, Alfin, no response at all. Clear?
Yes, sir.
That is what. Okay. Next, second one. What is that, guys? Latent heat of fusion over. Next one is what?
Vaporisation.
Latent heat of vaporization.
Latent heat of
Vaporization.
vaporization. Okay. So that is what it is. For example, if you take boiling point of water. What is the boiling point of water?
100 degrees Celsius.
100 degrees Celsius. Okay, that is what. So write it. The amount of heat required to convert respond how much to convert 1 kg of what? 1 kg of liquid into what
Yes.
state, guys? Gaseous state. At what pressure? Agalya, Shivani? At atmospheric pressure. Atmospheric pressure without changing its what? Without
Temperature.
changing its temperature. Means what temperature it is? That means what temperature it is? Everybody. At its what temperature, guys?
Boiling point.
At its boiling point is called, what is to call?
Latent heat of
Is called latent heat of vaporization. Enara Kishora writing understood or not? Yeah. So by the time, whatever the heat energy we are supplying, it will helpful to break the what, guys? It will helpful to overcome the force of attraction between them. Is it okay, guys? Understood or not? It will help to break the what? Force of attraction.
Sir, one doubt, sir.
Yes.
Until it will gain what, sir? To break the force of attraction, it gain energy, sir.
Yes, it will absorb the energy. So that is why by that time, whatever the heat we are providing, it will completely will be useful to break the bond. Understand, Mari?
Yes, sir.
Yeah. Till that, it will helpful to rise the temperature, Mari. So once it will reaches to the boiling point, by that time that energy will be useful to break the bond. Clear?
Yes, sir.
So 1 kg of water at 100 degrees Celsius, same way. 1 kg of steam means water vapor at 100 degrees Celsius. Can you tell me who is having more energy? 1 kg of steam or 1 kg of water? Completely. 1 kg of 1 kg of water. Who is having more energy, guys? Yes, please.
Sir,
Yeah, steam. That is what. So how much energy it will take, you know, guys? Heat absorbed to change from 1 kg of water at 100 degrees Celsius to 1 kg of steam at 100 degrees Celsius is extremely high. 22.6 into 10 power 5 joules. So this much energy is needed to boil the 1 kg of water from liquid state to what state? Everybody? Yes?
Yes.
Yes, please. Respond. Due to this reason only. Now, have you all experienced everybody? Now I will say one real life thing. Suppose boil liquid or like hot water, if you put a hand, you won't feel much pain. But if you are opening the steam plate, like for example, like idli plate, or you can see your mother is cooking and you suddenly went and opened the plate, your hand will pain, your hand will feels more burning as compared to the boiling water. Have you all experienced it? Everybody?
Sir,
Yes.
because steams get settled on that plate, sir.
No, not only that, Mari, because it's extremely high. Gaseous state, without it, the steam will falls on our skin. It will condenses to form the vapor, and it will take more energy from our body. Do you understand, Mari? That is the reason burning action is more. Clear? Understand what I am saying? So when the steam will touch our body, it will take about how much energy? 22.6 into condenses. Understand, Mari? Reverse. Suppose the steam will falls on
Yes,
our
sir.
body, our skin. What will happen? To convert into solid state or liquid state. To convert into liquid, how much energy it will release? It will release the 26.5 energy of joules. It will release us. Absorb to convert and releases back also. Clear, guys? That is why. What is the law of conservation of energy? Energy neither be created nor be destroyed. Understand? So for converting from liquid to gas, it will take this much energy. Then converting from gas to liquid also, it will release this much energy. Is it okay, guys? All of you? That is the reason. If the steam
Yes.
will fall on our skin, then the severe burning will take place. Very, very painful also. That is the reason when you touch the lid, which is like a steam, idli bowl and all, you can see, it is very, very hot. You people cannot touch it. But normal boiling water, you can. But here steam is extremely dangerous because it will release us, it will gives out or releases, gives out. How much energy it will gives out? Everybody, it will gives out 22.6 into 10 power 5 joules of energy. So it is like more than the boiling water at the same temperature. So due to this reason, the steam causes severe burnings compared to the boiling water. So which is more dangerous? Steam or boiling water? Everybody? Yes, steam, because steam is having more energy at the same temperature. So you suppose 100 degrees Celsius boiling water, 100 degrees Celsius steam, if I put it on the skin, so which will causes more burning? 100 degrees Celsius water or 100 degrees Celsius steam? Everybody? Steam. Understanding? So it will releases more energy. So this is what about it. Okay. So I hope you all understand what is latent heat of fusion and latent heat of evaporation or vaporization. Is it okay, guys? Everybody? Yes, please.
Sir.
Then, so this is all about solid to liquid, liquid to gas. Then tomorrow's class we are going to start reverse process. That is what? Solid to liquid, sorry, gases to liquid, and as well as liquid to solid. That is what? Condensation and as well as freezing. And if possible, sublimation also will study directly from solid to gas or gas to solid. So once that is over, then only we are having effect of change of pressure. So once effect of change of pressure is over, then we will discuss about evaporation and factors affecting the rate of evaporation over. Then this chapter is almost completed. So hardly next 3-4 days we'll complete this chapter. Okay, guys. Hope you all understand the today's class. Any doubt? Let me know. Clear? Is it okay, guys?
Yes, sir.
Yeah. Thank you, everybody. We'll meet in tomorrow's class. Thank you, everyone.
Thank you.